Explaining the cardiac cycle graph. Pressure changes. If the pressure behind the valve exceeds the pressure in front of the valve will open. Let's see. So if we have pressure here, and that pressure is greater than the pressure here, then what will happen is that the valve will open. Conversely, if the pressure in front of the valve exceeds the pressure behind the valve will close. So if this gets bigger, and is now bigger than the pressure behind it, then what will happen is that the valve will close again. It's important to fully understand that for the next section. So, this graph. Key things to remember on this graph are what each line represents. So, in this graph, the red line represents the pressure in the aorta, the blue line, the pressure in the left ventricle, and the green line, the pressure in the atrium. Here, we have our first key point. So, what has happened here is that the pressure in the ventricle exceeds the pressure in the atrium. So what that is going to mean is that the atrioventricular valve will close. That's going to cause the pressure in the ventricle to increase further, which is shown here by the increase in the height of the line. Okay, so here at point 2, the pressure in the ventricle is now higher than the pressure in the aorta. That's going to mean that the valve between the ventricle and the aorta is going to open, the semilunar valve, and blood is going to flow from the ventricle into the aorta. At the same time, ventricular systole is happening, so the walls of the ventricles are contracting, and so the pressure is going to continue to rise for a little bit, as will the pressure in the aorta. But eventually, the pressure in the ventricle is going to drop below the pressure in the aorta, as shown at point 3. And what's going to happen at that point is the valve between the aorta and the ventricle is going to close, preventing the backflow of blood, so preventing blood from going from the aorta back into the ventricle. That's going to mean that the ventricle pressure is going to drop, and eventually it's going to drop below the pressure in the atrium, and you can see that that coincides with ventricular diastole, so the relaxation of ventricle muscles. So at point 4 here, the pressure in the atrium is greater than the pressure in the ventricle, and that is going to mean that the atrioventricular valve opens and blood is able to move from the atrium into the ventricle. And so all along here, that is what is happening until we get to this point here, which is the same as point 1, where the amount of blood in the ventricle is now so great that the pressure of the ventricle exceeds the pressure of the atrioventricular valve closes, and the cycle starts over again. You can see down here that we've got the 3 phases of contraction and relaxation, and that atrial systole coincides with when the atrioventricular valve is open, moving the blood as fast as possible into the ventricle from the atrium. That's really all there is to it. It's a simple graph of pressure changes. So what we suggest now is that you make a large diagram of the cardiac cycle graph and annotate it. When you've done that, you could try and do the questions on page 106 of your green question book, and then obviously come and see me if you still don't understand.